All right, for those that don't know me, I'm Andrew Grimberg. I work for the Linux Foundation. I am the release engineering team lead for the foundation. Also with me is Thanh Ha, right over here. He's our release engineer for Open Daylight. So I'm going to basically be giving a brief overview of where our current situation is for the CI environment and where we're going to plan on moving with Boron. So what we currently have is we currently have our build environment hosted in 2 clouds with Rackspace on their public cloud. We have one in Dallas, which is our primary release engineering cloud. We have our sandbox system in Chicago. What we're going to be doing over Boron is we're going to actually start migrating these environments into a private cloud that we had Rackspace build for us at the end of last year. I know it's a little bit into this year already and we haven't started moving into it yet. There's been various reasons for that. But we are right on the cusp of actually starting that migration. In general, you should not see much from the end user point of view of the changes outside of a few outages here and there as we migrate data and then flip over to the new systems. So that shouldn't be too much of a problem, but I just wanted to bring that up. Part of the reason we are going to be doing all these changes and you'll see these outages is our current version of Jenkins is several months old. We held off on updates because we didn't want to interrupt Beryllium. We are a minor point revision behind on Gerrit and a minor point revision behind on Nexus and several of the other components of our CI infrastructure. Basically, we paused updates for. So the other reason is that we have most of our systems still on CentOS 6. We'll be moving everything up to CentOS 7 in this migration, and it will help us improve the configuration a whole bunch. As I said right here, both release engineering and the sandbox will actually migrate into this private cloud. We will continue with the access to the public cloud, but we'll use it for burst capacity only. When we were building out when we were doing our capacity planning with Rackspace, we determined that our current sizing that we got for the private cloud would match our current public cloud configuration. And yes, we're aware that during Beryllium, we started running into resource caps again, as we had every time we've come up to a release. But we will have the ability to burst into that particular environment this time. So essentially, we are doubling our capacity as soon as we do this migration. As well, we'll also be doing all these upgrades for the various components. In addition to all of these, we will be bringing in 2 new components that we've been talking about for over a year now, Zool and NodePool. For those of you that work in OpenStack, you'd probably be a little familiar with these 2 particular technologies. We are moving towards them for a couple of various reasons. And one of them is that Zool itself replaces our Gerrit triggering system. It also replaces the primary Jenkins queue that we use right now. Both of these are very big reasons for us. The Gerrit trigger system, as we found with newer versions, which we're not currently running on our infrastructure, do not pick up changes when we push new updates to our jobs. So if you've got a Gerrit trigger and you update your job, you actually lose your triggering unless we go through and do some manual configuration. With almost 2,000 jobs, that's not going to fly. So Zool takes care of that component. It also takes care of the Jenkins queues that we currently have. You're probably very aware that we have very large Jenkins queues when we're under a lot of load, and that actually puts a lot of strain on Jenkins itself. Jenkins UI is actually single-threaded, if you didn't realize this. So the more people that are watching Jenkins, the slower Jenkins gets. The larger the queue gets, the slower Jenkins gets. Moving the actual trigger queue into something off Jenkins is where we're moving with Zool. Zool also will give us the ability to eventually do clusters of Jenkins. So it can actually manage jobs and distribute them across multiple Jenkins masters. And the final component of Zool that's really good is that it actually has its own dashboard. So we will be encouraging folks not to be touching Jenkins directly, but to touch Zool instead. So yet again, we don't slow down Jenkins. And then we also have here with Zool, we have predictive merge pipelining. So it also does, when you've got multiple jobs that come in, or multiple how to put this. If somebody releases an entire patch set, Zool will actually start an entire series of merge jobs in the background that it won't complete, but it's predictive. So it'll say, okay, if this job completes, go ahead and go on with the next one and the next one and the next one. It will actually give you back a report essentially of what one breaks the series and if others in that series could be rebased and still continue to work. So we haven't tested it too much because the one location we're starting to use Zool now in right now is very new, so they don't have a lot in there. But we'll be figuring out all of that in the upcoming future. So node pool. Our current infrastructure uses a plugin to Jenkins called JClouds. JClouds does all of the dynamic slave buildup, tear down, what have you. Unfortunately, it's rather dumb. It tends to forget slaves that it's started to spin up that don't connect properly or that came up in an error state. It also links into the same thread for the Jenkins UI that everything else does. So a problem with JClouds causes problems for Jenkins across the board, which is why we see our build queues suddenly spike sometimes because a particular builder died and JClouds forgot about it. That's usually what happened. So we're moving to node pool because it takes strain off of Jenkins. It also manages multi-node labs better than JClouds does. What we do is we'll actually define our labs in node pool, and before that lab connects to Jenkins, the entire lab will be online instead of having to wait for these subnodes to come online first. So it'll speed up the startup of our multi-node labs, but it also guarantees that those labs will be completely working. Sometimes we have our labs that come up. We've got a couple slave nodes that don't come online, and we don't detect it until the job actually tries to start. So this should relieve that particular pressure as well. It also does slave image builds. So right now we have a Vagrant system where folks submit changes to Vagrant, and then either Thanh or myself actually have to go in and manually rebuild the images and then hook them back into Jenkins. Node pool has the ability to build slaves on a regular basis, so it'll actually take definitions that we give it, and if definitions are currently out of date, it will actually rebuild them, and so snapshot those behind the scenes for us and start using those. So we'll start getting to the point where changes into our build slaves will actually be more automated, and we'll be pushing more and more into baking things directly into our slaves. That does not mean that Vagrant's going to go away. We can actually use the scripts that we're using for Vagrant, which means that the Vagrant definitions we have now, because we're moving into a pure OpenStack with the private cloud, we'll be able to use those Vagrant definitions against base images that are external to us. So folks will actually be able to start using the exact same images that we use internally, externally. And then we also have the final component of node pool is that it watches the Zool queue itself. So as I keep saying, we don't want things looking at the Jenkins queues. So node pool watches the queue that Zool is managing. So it does all of its predictive spin ups and spin downs for us that way. And then it also has a metrics dashboard so that we'll be able to start watching the metrics of our usage a little better than trying to grab that information out of Jenkins, which unfortunately doesn't have very good metrics. So I went through that rather fast. And I'm sure there are going to be a lot of questions, not necessarily now, but in other breakout sessions. If there are any specific questions for right now, I'm willing to entertain them. But if there are things that are going to need deeper discussion, I will definitely entertain breakout sessions later.
You kind of touched on this, but what does the definition for nodes look like in node pool? Like we currently have the spin-up scripts and stuff, but you said we can still use those, or is it
well, so
repeat the question?
Okay, so the question is, what do the definitions for nodes in node pool actually look like, right? Yes. What we have is node pool, just like Zool, take YAML files for defining how systems are built out. One of the definitions in that node definition is, what script do I use to build this? Or how do I build this? We have another option for using another component from OpenStack called disk image builder, which actually takes a raw disk image and then builds out the disk without actually spinning up a system and snapshotting from that. We're not going to go that route right now. We're going to go with the standard snapshot route as we kind of do with Vagrant. So we will define in our scripts that it uses a upstream base image of Ubuntu or Fedora or CentOS or what have you that we actually grab from the upstream vendors, from their cloud images, and then we specify use this script to build it. So right now our Vagrants, if you look through the Vagrant definition, has essentially we've got a couple of phases. We've got do this basic configuration, do the node definition, and then we have this one other component which is munge the networking essentially to work in our current environment. That last part goes away completely with the private cloud. The other two components though are going to stick around, but we'll just link those together in the initialization script. And so that's what that's basically going to do. We're going to continue using the scripts that we use for Vagrant. We're just going to move them into node pools usage of them. So we're not going to bake the scripts directly into, we're going to continue not baking the scripts into Vagrant. We're going to keep them on the side that Vagrant calls. Over there. The question is if we have any plans for third-party CI. So we have actually had the ability for third-party CI for quite some time. The only question for third-party CI is, well, it's not so much a question, is what you really need to do. If you want to hook a third-party CI into our Garrett system, you need to create a user account in our identity system. Let us know what that particular identity is, and we can actually grant it the streaming capabilities so that it can actually watch the Garrett event stream. And then you can hook up your own CI to the system, and it will have the ability to actually do verification votes. So we've had that capability for some time. We've told folks whenever they've asked us how to do that, it's an option. Nobody's taken us up on it. But it is available. Marcus.
With the new private cloud, is it possible to use a Docker image in place of a VM?
Okay, the question is, in the new private cloud, if it's possible to use a Docker image instead of a Vagrant image, right? Or a VM. We are still running on top of OpenStack. OpenStack has the ability to do Docker. We have not worked with Rackspace to see whether or not we can do that cleanly. So I would say we would have to investigate. As it stands right now, we do have a system in our environment right now that does Docker. So we have a build slave that does Docker on top of it. And that would definitely be something we can easily port. But if you want to do Docker directly instead of spinning up a VM that then does Docker, we'll have to do some investigation. It's likely to be something we can do, but we may have to work a bit with Rackspace to get the environment configured to do it.